And what?
You already typed it in? Okay. I'm stopping the bell ringer in just a second. Okay. So before we start looking at different answers, I got an important question. What's the first thing we should have immediately found out about this function? The rate of change, right? Because of what? It tells us what type of function we see here. Okay, so 48, 40, 32, 24, 16. Then we have 24, 18, 12, 6, 0. So I have an important question. Who thought that this was a quadratic function? Anybody? Anybody think it was a linear function? Who thought it was exponential? Who doesn't want to raise their hand because they're scared? Marcus. Guys, get engaged in the conversation. It's okay to be wrong. So we have more people saying linear out of confidence. So who thinks linear and why? Or someone who said linear, tell me why. Sanaya. It's adding 6 on the right hand side? Is that true?
Yeah. Oh, negative. Oh, okay.
Is it subtracting 6?
Yeah.
Okay. We need to pay attention to that. By the way, don't forget, could you have written down the table and made it a little bit easier to find that rate of change?
Yeah.
Yeah, a little bit. Okay. Is that all that mattered for it to be linear though?
No.
What else do I need to look at? You always have to look at both sides. This was not subtracting 6. Well, it was subtracting 6 every time the x adds 8. Or subtracts 8. Don't let me lie to y'all like that. Right? We need both of those. So Jamarcus, what type of function do you think this is?
I don't know.
You don't know?
No.
Hazard a guess? We're repeatedly subtracting by the same amount every time?
You don't know.
Okay, can someone help him out? And we need to learn this. Jamarcus has been working on this for 2+ weeks now. Come on. Subtracting by the same amount every time. If it's constant additive, with subtraction is a type of addition. Right, Z?
Yeah.
You engaged? Focused? If it's constant additive, it's what type of function? It's linear. Right? Remember, for it to be exponential, it's constant what? Multiplicative. Okay? So constant additive versus constant multiplicative. And I need y'all to hear me clearly on this. I'm going to have your understanding checks back to y'all later today, at least the one about the type of function. And a lot of us talked about repeated addition, that's all we said. But it's not just repeated addition. Remember, a quadratic has a type of addition in there, it's just linear additive. It's constant addition. We've got to know that. As soon as we say y equals, or as soon as we know it's linear, y equals what? mx. That's right. Y equals mx plus b. That's slope-intercept form. And remember, like, we want to know type of function, so we know the equation, so that can help us think about it. Because now I know, oh, I need m. How do I calculate m, my slope? It's been a minute since we've done a linear one, but we should know linear equations. How do we calculate m, the slope? Rise divided by run. But we don't have a graph right now, we have a table, so how do we rewrite that for a table? The Greek delta symbol, but remember that means the change in y. If it's rising, thank you, right? If it's rising, isn't that a y value? Change in y divided by the change in x. Remember, guys, these are not like random equations. I'm not making something new. I'm just rewriting it for the situation I have. Change in y is my rise, right, Jalen? You engaged? I know it's Monday morning, but we got some learning to do today, right? Change in x is the same as my what? From the graph. It's the x, right? But it's the, what were you talking about earlier, David? Rise divided by run. So the change in x is my run. You can use that rise divided by run to help you think through this, but we need to recognize that, right? I see one answer right here, 8x plus 6y. Notice that person is looking at both of those rates of change, right? But we want to notice negative 6 divided by negative 8 is 3/4. That's my slope. And we got to remember that we need the y-intercept. So how am I going to get that y-intercept? I got to keep it going, right? What do I need to keep going until I get? What am I going to keep? How do I know when to stop? Get what to be 0? Because I have a 0 right here, right? And so minus 6 is negative 6. Minus 8 gives me a 0. Minus 6 gives me a... Okay, so now I have my pieces. F of x equals... So I can do the negative 12 first, but then I would need what? Plus 3/4 x. If I'm using this, right, so I went off the negative 12 that Ethan was trying to use, but if I'm basing it on this, right, it would be a slope of 3/4 times x, then minus 12. Remember, both of those are correct, because what mathematical operation shows that constant additive rate of change? Say it louder. Multiplication. That multiplication by x defines that constant additive rate of change. Marcus, do you feel better about that linear function now?
Yeah, sure.
And I think, because I thought I saw you doing it earlier, like it felt like you just kind of assumed it was exponential because we've been doing exponential a whole lot when you're writing your equation.
I know exponential for the one that's zero and x.
Say again.
I mean, I knew it wasn't exponential for the one that's 0 and x axis.
Okay, so be careful. So one, and so I'm glad I asked this. Remember, we need a 0 for the x value, because that gives me my y-intercept. But does that y-intercept ever define the type of function? Don't be careful about that. What always defines the type of function? Naisha, I think, said it earlier, maybe Rakai did at the very beginning. One of y'all too. What always defines the type of function? The rate of change, okay? So we have to focus on the rate of change. Because notice, I can keep this going to get that y-intercept. And it's the x value of 0 that tells me what the y-intercept is. Does that make sense, Marcus? Okay. What are your questions about this type of function, writing this equation? I'm doing this for a little bit. I'm planning on having a test on Thursday. You need to know how to write the equations. If you don't know how to write those equations, we need to start studying tonight for that test on Thursday. I've been working on this unit for about 3.5 weeks, maybe a little bit longer. I'd have to go back and look. We got to know how to write those equations. All right, let's get started with today's actual lesson, though. What the stuff we're learning now, the practice ideas. We are going back to the textbook. And so we're not going to new groups today because we just started this lesson. But we're going to continue activity 4.1, forms of quadratic equations and their features. We're going to move into the graphic organizers pretty quickly because I think we finished figuring out which equations went with which graphs on Friday. Does that sound right? Yes? And then we're going to move into activities 4.2. And I think I'm going to stop at 4.2 so y'all can work on some Mathias stuff that will be a homework assignment that's due, I think Wednesday is when I have it set for, but you should be able to knock it out today, hopefully. Okay, so we're on page M1-51. Let's go ahead and open those textbooks. M1-51. Alright, so we're on this lesson true to form. We're learning about what type of function with this lesson? Quadratic functions. Specifically, we're looking at those quadratic equations, right? And figuring out the features of those quadratic functions that go with each equation. Who wants to read our objectives to get us started? Go for it, Lily Kate.
I can identify the features of a parabola based on the form of a quadratic equation.
Okay, Jacoby, give me one feature of a parabola that we're going to be looking at today. Concavity. Desiree, give me one more. The vertex. Sanaya? Concavity, vertex, line of symmetry. Preston?
That's all I can think of.
That's all you can think of? So remember, those are the three that are unique to parabolas, but there are two more that we're always going to look at for relations. X and Y intercepts, right? Where it intersects the X and Y axis. Okay? So you got to remember, we're always looking for those intercepts. Alright, so those are the features that we're looking for today. Alright, we should already have this on our notes, page M1-54. And so remember, and I would recommend this highly because it looks like a lot of us don't fully know this information. I think a great tool is maybe a Quizlet. You make that for yourself, or maybe you make flashcards or something like that, where you write down the equation on one side and you write down the name on the other side to make sure you know these things. You can do that with linear and exponential functions as well. But we got to know these different equations. You're not going to have your notes on these tests. These are things that you can know. You got to study them. You got to put in the time and effort. You got about 4 days is the plan. All right. So if we have standard form right here, what feature can we quickly see in that standard form up at the top? The y-intercept. Which part is defining that y-intercept? C. Is there anything else we can quickly see in standard form? What's giving that concavity? I got one person engaged. A, right? Now remember, A itself is not the concavity, but the parabola is concave up when? When A is positive and is concave down, when?
A is
A is negative, okay? So factored form. Now, I'm not asking for the feature right now. What does R1 and R2 stand for? Why are we using that letter R? Roots. And roots are what? This is the feature, or is part of the feature. Roots are the X values of the x-intercepts, right? So we are looking at x-intercepts there, but I want it to be clear, right? When we say roots, we're talking about the x values of the x-intercepts. And again, we have A, which is going to define our concavity. And then we have our vertex form, which is probably the most useful, and it tells us right away one of the main things. We have the what? Vertex, right? It's vertex form. And what really important line has to go through the vertex so we can see it very quickly as well? The line of symmetry, okay? And then concavity there as well. So we worked through this. We're going to bring this back in a little bit. Do not forget, we found out that there are other ways to get that vertex. This is the sheet that I created with some other teachers around the county. We found out that even if we don't have vertex form, we can find the vertex in standard form. How did we calculate the vertex, or the x value of the vertex, when we had the standard form here? Say again? We're going to eventually substitute, but we had to. I need the x value of the vertex first. Look at the information there.
H?
Huh?
Is it H?
So h is the x value of the vertex, and that's always in the vertex form. But how am I going to calculate h if I have standard form? Standard form doesn't have an h in it. There's an equation there that tells us the x value of the vertex.
Negative b divided by 2a.
If I take the opposite of b and I divide it by 2a, that gives me my h, my x value of the vertex. And then to get k, I do what? I substitute it in, right? This is an equation that you're going to have to study. You got to know. You got to know that thing to be able to calculate the x value of the vertex. Now, if you have factored form, it's a little bit easier because the vertex is right in the middle of the what? Say it louder. The roots, right? If you draw a correct parabola or an accurate parabola, that line of symmetry is in the middle of the roots, so we just average them. And then what do we do when we get the x value of the vertex? We substitute, right? The pattern has not changed. It is a pattern that we need to know. We just have to figure out how to get the x value of the vertex. Okay, so here's where we are, right? Did we finish gluing our equations to the graphs? We did already finish the gluing part as well. Billy Kay says no. I know we identified which equations went with which graphs, but y'all finished gluing? You finished gluing? Okay, so go ahead and get those out. And what we're going to do is we're going to go to page M1 dash, I did not write it down, 73? Okay, there we go. M1 dash, I think it actually starts on, oh yeah, 73, there we go. So M1 dash 73 is where we should be. Okay? And so we're going to glue our graphs and our equations down. And we've already identified these things, right? Yeah, that's how we did it. So graph A, which had equation B, was the first standard form. So let's go ahead and put that graph and that equation in. Did y'all identify or write down which equations went in which form? No? Okay.
I thought we were going to do it.
We did, and then I erased them for the later classes. So we'll go through it together. I know we did it together, but graph A with equation B goes on standard form along with graph D and equation F, and graph C with equation H. So the glue should still be in the pink containers. Get that out, share it, but quickly glue it down, right? So glue the right ones down. The rest of the glue for this group. And what? There it is. Okay, I'm gonna write. Okay. Graphs A, D, and C. Y'all not have enough glue for it?
What do y'all think?
Say again.
Yes.
This one? Go ahead and lay out the ones that you need here, though. So see how these are the standard form here?
Bro, you did click that.
Hey guys, make sure you're gluing your graphs and equations down to this graphic organizer. And don't forget, guys, you do not need to put a ton of glue on there. Just enough to get it to stick. If anybody, I also have tape if there's not enough glue at your station. Anybody not have glue to use?
Long story short,
Everybody has glue?
now somehow called cats and dogs.
John, is your second glue? Those only going to be just because these are plastic. Okay. Hey guys, we're only looking at standard right now, right? There are graphic organizers for the other forms after this. Okay. Kia says, it looking like the glue is running low, so I need to buy some more? Yes? Okay. I'll start to get some more glue. Alright. So here's the important part. So you have examples of graphs and equations under standard form, but what we really need to focus on right now is identifying how do we get these key characteristics, okay? So when I talk about the axis of symmetry, how am I going to find the axis of symmetry from standard form? How are we going to do that? How do we get that axis of symmetry using A, B, and C? Huh? Well, I mean, so yes, we can get y-intercept. Okay, let's do this really
Did you
quickly.
say D or B?
D. A, D, and C. Graphs A, D, and C. I think equation B is with graph A.
Yes.
Okay, let's do this. Quickly, let's circle the features we can easily see from standard form. which features can we easily see from standard form? Y-intercept and concavity, right? Those are the ones that are easy to see. We can still get at least two of these. There's one that we cannot get yet. Concavity. If A is greater than 0, concave. What? Up. If there you go. If A is less than 0, concave. Down. Like a frown. Make sure you can identify that value for A. What do we know about the y-intercept? What? Okay. Good. Hey, let me ask this. This is a key detail. What should we know about every y-intercept that has ever existed? Not just the parabola or the quadratic. So for y-intercept, x is always equal to 0. So what is the y-intercept? 0, comma, c. Right? It's the y value, but if I substitute 0 in, all I'm going to get out is that c. So you have to be able to identify what that c is. Notice we have circled the features that are easy to see, but we can get two of these other features as well. So, now I come back to line of symmetry. Aiden, David, what's going on?
He had somebody else's book, and this whole time he thought that, like, he was recutting the stuff out. He's like, I know I already cut it out, but it wasn't even his book.
Where's your book, David?
I don't know what came.
Wait, did you just take it out from under your desk and yours is in your backpack? Stuff happens. Alright, let's refocus, let's regroup. Axis of symmetry, right here. What is the general equation for axis of symmetry if I had vertex form? Right, if I had vertex form, remember it would have to start out with x equals, because it's a vertical line. X equals what? H. But we don't have the vertex form. We don't have an H. So how do we calculate H? This was something we did on, trying to find it. See this? This sheet of paper. We looked at how to identify the axis of symmetry when we have standard form. I would get this sheet out. This is the whole point of this sheet, is to identify the axis of symmetry and the vertex, even if we do not have vertex form. Say again. It involves the A, but there's something else with it. So remember, with standard form, that H, it is the opposite of B divided by 2A. H is the opposite of B divided by 2A. That is the axis of symmetry, right? Okay, remember H is only in that vertex form, but what we see is that negative B divided by 2A is the H in standard form. This is H, quotation marks. There we go. Okay. And if we know what H is, if we can figure out the x value of the vertex, how would I figure out the vertex now? Jacoby said it 2 or 3 times earlier. We're going to what? Remember, x is my input, so I can substitute it in and get out my output, which is going to be k, right? So, this is so I'd say also x value of vertex, right? That's the whole point of the H. So substitute in to get K. Y value of vertex. this is one of those cases where there's a lot of information there. If you understand why, it becomes very easy. I need the x value of the vertex because that's my input. So I substitute it in to get my output. Miracle, do you need me to read anything?
Can you read what's under vertex? Tevin had kind of used.
This word vertex right here.
Can you read the whole thing?
So substitute in to get k. Remember, k is the y value of the vertex. Did you get that, or I need to reread it? Okay. But also, Miracle, don't forget, you could say it a little bit nicer. Okay.
I'm sorry,
Just more respectfully, you know. All right, so x-intercept. Is there anything that you know about the x-intercepts? And so be careful, because I will say this: a lot of students try to put values from the vertex into the x-intercepts, but remember, the x-intercepts are very different. They're connected, but they're not the same as the vertex, right? Vertex is here. But what should we know about every x-intercept that has ever existed? Okay. Say it again. Y is what? 0. Remember how y-intercept, the x is 0? So for an x-intercept, y is 0. Think about it, because those are you're looking at, that's crazy, Mr. Kenny, but right here, that's a y value of 1. Here's a y value of -1. So what is the y value on the x-axis?
0.
That makes sense now? So ask those questions, right? Don't just give me a blank look like, what? No, ask that question, right? Y is equal to 0. But notice, that means I would get 0 equals ax squared plus bx plus c. You don't know how to solve that yet. That's what the next unit's about. Technically, you learned in Algebra 1, but... I know. You'll start to recognize some of it when we get there.
I've heard it before.
Yeah. It's something called factoring and completing the square and the quadratic formula. We'll get there. So, hey guys, hear me out clearly on this. The x-intercept is the only feature from standard form that I will not expect you to get. Now, I still expect you to know that for an x-intercept, the y is 0. But substitute that 0 in, just tell me, alright, I don't know how to solve this from here, Mr. Kenny. Okay. Make sure you're attentive to these details. The details matter. Okay? Jalen, you good? Almost there? Not at all? Okay. Can I erase the top row? Or the top set? Okay. So I'm going to erase this top set so that we can look here. So factored form is nice and easy because we are, and this is the next page, we're literally multiplying factors that have those roots. We had graphs B, E, and F identified last week. So B, E, and F. Is it gone? Dang, no, man, I was this close down. I also have tape, if anyone needs tape.
He said, I just feel like we should learn something to go back to school.
Say again.
I should go back home. No, we make you there.
We're not doing that in the middle of class. I should have just done it already, that's my bad. Yeah, but you're gonna have to, this is why I'm out of glue, this is why. Because you just have a stick right there.
Wait, how did, oh my bad. Hey, real?
What's up? It's still written on there. What? Okay. So.
What else did you do? Everybody's like, I like this. And
We got
So you're running there. All right. So D, E, and F with the correct equations. Right? B, E, and F. My bad. I just said D, but I meant C. Okay. I was saying I can bring tape around if you want extra tape, or you can come get it from the student work center later. If you want to get those edges down. Huh? Yeah, where all the student materials are up front. All right. So factored form. Let's look at factored form here. Which features can we quickly and easily see in factored form? Concavity always. I'm just going to put same. Are y'all okay with me putting same instead of rewriting the whole thing? Okay. Concavity has not changed. What other feature can we quickly see? The x-intercepts. And that's based on the what? Based on what? Roots. So, what are the x-intercepts then? Based on R1 comma 0 and R2 comma 0. Remember, this is not the first time we're seeing this. Where else can we see this information? Remember that Desmos exploration we did, and we first discovered all these different features by manipulating the sliders on the Desmos thing? Is there anything special we need to remember, though, about our roots?
Opposite.
We need those opposites from what's in the equation. Because it's x minus R1 and x minus R2, R1 and R2 are the opposite of what is in the equation. And that's one of those cases where, once again, you can memorize it, but if you know that it's x minus R1 and x minus R2, then you know that you need the opposites. What's up there, Zach? Okay. Alright, axis of symmetry. It's not right there with vertex form, but we did talk about how to get the x value, the axis of symmetry. How do we do that with, or sorry, it's not in factor form. Average the, so be careful, just mathematically on language. We're not going to average the entire x-intercept, we're just going to average the roots. And how do we average something? Add them up, divide. Now it's only 2 in this case because we added 2 numbers, right? So it's just adding up however many numbers there are and dividing by how many numbers we have. What do I need to read out, Marshall?
The x-intercept
right here?
Yeah.
Is in the, that's EQN, is an abbreviation for equation.
What's it say above equation?
Opposite of what is in the equation. Right? We need the opposite of what is in the equation. right? And that is why we are averaging those roots, because h is in the middle of the roots, right? H is in the middle of the roots. Okay? What about vertex? No, we're still writing. Huh? Substitute what in? H, right? H equals R1 plus R2 divided by 2. So substitute H in, which remember that's the R1 plus R2 divided by 2, to get output of K, right? So H comma K, which form is that, which form of the quadratic equation are we getting H and K from? The vertex form, but still that's the vertex, right? Even though we're not looking at that vertex form, we do want to recognize like H comma K just means the X and Y value of the vertex. So does anyone know a way to get the y-intercept out of that factored form? Jose, do you know anything about the y-intercept? Nothing at all?
Oh. X is 0.
X is 0, right? We haven't looked at the y-intercept from factored form, but we know for every y-intercept x equals 0. So what could I do with that 0? I can substitute it in, right? Plug it in, is that the mathematical, technical way to say is substitute in? So substitute 0 in. The output, right, will be the y value. We'll look at some examples like this later. But I do want you to just recognize that if we substitute the 0 in, the output will be the y value of the y-intercept. You just have to know that the y-intercept has an x value of 0. Right? X is equal to 0. So substitute 0 in. The output will be the y value of the y-intercept. I probably should have capitalized because that's the beginning of the sentence. Yeah, the n there was not an abbreviation. It was the word n. Once you're done writing that, obviously the last 3 graphs go under vertex form. Go ahead and start writing or gluing those in. If you need tape, let me know. I can distribute. I got 2 different things of tape. Yeah. There you go. Put that there. Anybody else need tape? Go once, going twice. The order doesn't matter on the. Can I move to vertex form? No one else needs factored form? Oh, Marshall's still writing? Yeah, Marshall.
What did he say?
Alright, so we have, what did I put? I, H, and G. But I didn't put them in order. It's really okay. Dave, you done writing? Yeah? Okay. Alright, so there's our 3 equations. Alright, I need y'all to hear me very, very, very clearly on this, okay? In vertex form, can you see your x and y intercepts right away?
No.
No. The reason I ask this is, I regularly see students put this h value as the x-intercept and this k value as the y-intercept. Are those the x and y-intercepts? Do not put them as the intercepts. Those are the x and y values of the vertex. There we go. It's IHG. Okay? Alright, I'm about to have to move on, Haley, but here's the graphs. IHG, I goes with equation D, H goes with equation G, and there we go. Okay, axis of symmetry. This is the time when axis of symmetry is really easy to see. How do I do it? X is equal to H. Please do remember, do you need to write the x equals for that axis of symmetry?
No.
Yes, you do. Because if you don't have that x equals, you're not writing the equation of a vertical line. You have to have the equation. The whole point, remember, is that if I have this graph, the axis of symmetry is a line, and I don't know what the y value is, but I know every point has an x value of h, because it has to go through the vertex. Okay? The whole point is that vertical line has x values of h. Okay, vertex then, what is it? H comma k. By the way, is there anything special I need to remember about h or k? Say again. Say it louder. Yes, but there's something special about one of those two that I need to remember when identifying them here.
The H is alright.
It's x minus the h, so I need the opposite. Remember, I have that x minus. I need the opposite. So remember, these are the easy features to identify. Are there any other features that are easy to identify? The concavity, right? What always defines that concavity? A. And it's the exact same as before, right? So the concavity is always the same. If A is positive, the parabola is concave up, and if A is negative, the parabola is concave down, okay? Now, the x-intercepts and y-intercepts are not super easy to identify, but they're not terrible. Traylon, how would I find the x-intercept? Any ideas? None at all? Is there anything you know about the x-intercept that's always true about all x-intercepts? Okay, go back and look at your note under x-intercept for standard form. Go one page back. Go one page back. What note did you make under x-intercept? You haven't turned that page. What note did you make to yourself about x-intercept under standard form? Is that ever going to change? Remember, on the x-axis, guys, y is always equal to 0. So we're going to do what? We're going to just substitute 0 in for y. Now, don't forget that may appear as f of x, but we're going to substitute 0 in for y. And whenever the variable you want to know is on the other side of the equation, you have to solve. Meaning use inverses and properties of equality. We will look at some examples like this soon, but I bring that up because it is important where we understand the difference between solving and simplifying. So I'll show you one example in just a minute. So Z, do you know anything about that y-intercept? Oh, you still writing? My bad. Phoebe, do you know anything about that y-intercept? Nothing? There's nothing you know about the y-intercept at all? And I'll tell you this, you're not going to find this note on that paper, but there's something that we all know about every y-intercept that has ever existed. Think about the y-intercepts you've looked for in exponential and linear functions. How did you know when you had the y-intercept? So do we still know that? Okay. Just like with an x-intercept, y is 0. For a y-intercept, x is 0. So what am I going to do? Substitute 0 for x and simplify. I'm going to show you the key difference in these with one example. So here's a good little example if you need this. Maybe writing in the book or somewhere else, but clearly right away, what form do we have? Vertex form. Okay. Desiree, do you know what the vertex would be in this vertex form? 3. Okay. Anybody want to add on to or push back on that 3 being the vertex? Anything you want to push back on it? Or add on to it? Which one? Okay, you want to push back? Okay. 3 is the concavity. What do you think about that? Maybe? It is? First off, why do you think it's the concavity?
Because it's A.
Okay, so remember, this is where I would write out, I would know my equations, and I would write this out probably above it to help me visualize these things, right? A is 3. Now, I gotta tell you though, 3 is not my concavity. A is 3. What's the concavity? Okay, A is positive. So it's, there we go. The concavity is up. Right? A is 3, A is greater than 0, but the 3 is not my concavity. It just tells me what the concavity is. A is greater than 0, so it's concave up. Okay, so Desiree, look back again. Which of these values define the vertex, right? A was the concavity. The vertex comes from what? Okay, that's part of it. Look at what you wrote for vertex, though, or what we've written for vertex here. What does it say? H and K, right? So what's my H? It's the x value of the vertex, but look right here. Where do we see, so H is here, what would the H be then? A. It's part of the vertex. Come on. What is the H? What lines up with the H in the equation? So -5, is that my H? I need to switch, I need the, what's the mathematical word there? Opposite. So remember that they're like, these negatives are the same. So H is just that +5. So vertex is +5. Miracle, what would my K be then?
X. Would it be 1? What is it?
So we have the H of 5, I need the K now. for that
Oh,
vertex?
27. Oh, yeah. Sorry.
27, we give it 27?
Negative 27.
My bad.
I mean, we only need the
I
opposite
forgot it was K.
when it's
not
x
A.
minus, right,
I'm
yep,
sorry.
so negative 27. Now, I'm going to show you a quick example of how we would get the x and y intercepts. Okay, for a y-intercept,
Mr. Kenny,
yes ma'am,
so the 5, I see the negative 5, then you do the opposite. Why don't you do the opposite from the 27?
so you see where it says plus right here?
Okay.
Because it's plus k, to get a minus 27, I'm literally having to add
Right.
a negative 27. So
Right.
k is negative 27,
Okay.
right? It's x minus h, so
Right.
to get x minus 5, I had to put a positive 5.
Okay.
That's why. Good question. Okay, so for y-intercept, what do we know? X is equal to 0. So I have f of 0. Notice x, or 0 took the place of x. Times 0 minus 5 squared minus 27. Notice how this is a pretty big expression, but can I simplify it? Yes. That's why I said we're just going to simplify here. Right? I'm taking a larger expression, I'm using my operations to simplify. Do not forget to follow the correct order of operations. So my y-intercept is 0, 48. That's a pretty big y-intercept. Okay, do I need to clarify any of those steps I used to simplify there? And I'm not expecting you to be super quick with this yet, it's just a quick example. So there's my y-intercept. So what about an x-intercept? What do we know? Y is 0, right? Now remember, what is y in this equation? So I don't see a y in that equation. What stands for y? The output. For the y variable, right? So when I look at that equation, x is my input. What's my output? I'm saying, like, when I look at this, what is the output? Remember, that's y, so the entire f of x. My point is, guys, this entire f of x, that's my output. Notice what I'm saying is 0 is the input, f of 0 is the output. So f of x is my output. So that 0 takes the entire place of f of x. Okay. Notice how there's a variable with the numbers. This is when you would have to solve. When the variable is with those numbers, I need to isolate that variable using my inverses, something we have practiced. So 27 is equal to 3 times x minus 5 squared. Can anyone explain why I added 27 first? Why didn't I do anything else?
So eliminate.
But why did I deal with the minus 27 first?
This is like five,
That's closest to, but it's really like, it's the last operation being done. If I look at x, what's the first thing happening to x? It's being,
subtracted by 5.
remember parentheses happen first, right? So it's being subtracted by 5. After we subtract by 5, what's happening? It's squaring. After the square is being multiplied, and after the multiplication, I'm subtracting by 27. Right, so that last operation being done is the first one I undo. So following that logic, what's the last operation being done here? That times 3. So I'm going to multiply by 1 divided by 3. 3 divided by 3 is 1. 27 divided by 3 is 9. Now, this is what the next unit is pretty heavily on, so you don't have to know this 100% yet, but this is a quick little intro. What is the inverse of a square, though? Ooh, we don't know.
Inverse,
The inverse of a square.
define inverse.
It's the operation that will undo, you say times?
Oh, I know, it's the square root.
There you go, square root. The square root, what literally, a square multiplies a number by itself. A square root is asking, hey, what was multiplied by itself? Right? So the square root undoes that square. What was multiplied by itself to get 9?
I mean,
1 times 1 is 9?
no.
3 times 3 is 9? So the square root of 9 is 3. Now there's a tricky part to this, and this is what, again, the next little unit's on. What's negative 3 times negative 3? It's also a positive.
Oh, you said you.
Negative 3 times negative 3 is also a positive 9. So the square root of 9 in this case could have also been a negative 3, which should make sense, because how many x-intercepts do we normally have? There's my 2 x-intercepts. So x is equal to 8. And x is equal to 2 comma 0, and 8 comma 0. So the main point of all this was just I want you to see that quick little intro to the difference between solving and simplifying, but also do note, when I take a square root, how many solutions do I get? When I took that square root, how many answers did I get?
2.
2. 1 positive and 1 negative, right? And so that's something that's going to show up later. Now, as I said, it's going to show up later. So am I actually going to expect you at this point to calculate x-intercepts from vertex form?
Yeah.
We haven't really practiced solving this much, have we? So at least right now I'm not going to expect it, but next unit I will when we start studying it more. Okay? Alright, ready to move? I know, because we're ready to get up, use the board some. So we already did, I'll say this, we've already done all of this. I think we already answered A and B. This is back on page 54, so maybe 55? I lied, 56. M1-56. So we already did part A. What methods did we use to match each equation? We just looked at those key features based on the equation, didn't we? We looked at the key features based on the equation.
Yeah.
Okay.
You said what you talking
Analyze the 3 tables. So this is just C M1-73 to M1-75. Those graphic organizers, guys, are something you should definitely study to know those different features and those different equations. Right? I would study those graphic organizers on M1-73 to M1-75 to study. Okay. Alright, now we're going to get some practice in with what's happening, or with these things that we've talked about so far. So this is on the very next page. I'm going to let y'all work at identifying the different equations that can go different places. These are where the groups are going to be working. What I will note, okay. What I will note here is, what I'm going to ask you to do is I'm going to ask you to write the equations on the board that could go with this graph, right? So we're given a graph. We're going to circle the functions which could model that graph. So let's look at this first function together. f1 of x. What do you know about f1 of x? Just looking immediately at the equation.
Is R1,
So if you're talking about R1 and R2, you're talking about, okay, so that's got factored form. And you're talking about R1, what would R1 be?
1.
Close.
is minus 1.
-1.
Oh yeah, remember I need the opposite. R1 is -1, which remember that gives me the x-intercept -1, 0. So that gives me -4, 0. Notice we got factored form, so we're immediately looking at those roots. Is there anything else I know about that function? Parabola is concave down?
You right.
Right? A is less than 0, so yeah. Alright, there's my A. So based on that information, could it go with this graph?
Yeah.
It's a possibility.
It's a possibility. That graph is concave down, isn't it?
Yeah.
And it has negative x-intercepts? That could match. Let's contrast that with F4. Naisha, were you going to ask a question?
Oh, no, I was just,
Okay. Let's look at F4. Could F4 of x go with that graph?
No.
Why not?
Positive.
Concavity can't be positive. Let's reword that.
Okay, well,
Concave up because A is positive. Don't forget that. Now I will point this out. Could this y-intercept go with this graph?
Yeah.
The y-intercept would be what? 0, comma,
8.9.
positive or negative?
Negative.
Remember the standard form is always that value. So notice, is this going to continue going down and to the right? So does it have a negative y-intercept? So it has a negative y-intercept, but the concavity does not match, so it does not work. That would not match the graph. So that's what you're doing. I'm just asking you to look at the features that are clearly visible in the equation, identify which of those equations can go with that graph based on those features. What are your questions about those directions? Anybody? Okay, so I want us to put our answers on the different vertical surfaces. I'm going to give you a maximum of 5 minutes to analyze these 8 equations, just these 8 equations, right? We've already done 2 of them, so you're down to 6, right? Okay, so let's work with each other. Let's figure out which equations could go with that graph. We have those graphs. We have 5 minutes on the clock, starting now. Okay, 5 minutes is on the clock. Let's get up. Let's get moving. Yes, sir. Yeah, go to the vertical surfaces to write your answers. You can collaborate with those vertical surfaces, but you need to be at the vertical surfaces. What?
You said you can't tell me. You're like 30.
Can we rush this?
Yes, you can erase that. Guys, you've almost wasted a whole minute. We got to get going and get those answers up.
No.
This one, Mr. Kenny.
Yes, ma'am. Sorry, I forgot. I took some home to wash them and I left them at home. But there's one right there. What is it? It's not
What the fuck are you using?
You like the ones that just?
Stupid.
So you got
I'm trying to see. That's all.
Write more, write more, write more.
Just kidding.
Yeah. What's up? Okay. So, remember, right here, we looked at it, we said, that would have, -1 comma, R would be -1, R2 would be -4, so it has the x-intercepts.
You don't want that. I'll be breaking.
-1 comma.
I'm not breaking.
And -4 comma. We identified the form first. And remember, we have those words organized back on it. We now know A is equal to -2, so.
He should be going, he should be going on strike, don't let that happen. He just-
That parabola will be concave down. Okay? The x-intercepts are negative x-intercepts, that matches this graph.
Let's be intellectual black
Yes.
and Lily Kate.
So, that equation can go like that graph. We looked here though, and we said, in this case, A is 2, it's greater than 0, so that would be concave up. Does that go with that graph?
That's why.
So one feature was wrong, so it cannot go. So we're looking at these different equations to see which equations can go with that graph. Does that explain it? So look at the form first to see if it can go with it, okay? You're doing all 8. So you're looking at all 8, figuring out which, and just write out which equations could go with that. Okay?
Okay, let's get started, Lily. I had my dad as a
Whoa. Oh my gosh. Nice. Why would you say that?
That was not
Hey.
right.
Let's focus on our learning. And you can just write the equations, guys. We'll talk about the justification afterwards. Just write the equations that you think can go.
So just write the one that.
Just write the equations you think can go.
Only the one we think they can go.
Yeah, that's what I just said.
Oh, only the one we think
That's
they
what I
can
just
go.
said.
Don't call me that word.
Oh my
Okay,
gosh.
so let's
Okay, I was right, I was right there.
So, you can do this one.
Please. So you already said we use that one, right?
But we
I'm
gotta.
gonna write that one. I'm gonna write that one. Right? You still gotta write all of them.
No, we don't got it right.
Should I write it? Are you touching the bed?
You gotta put it on right. You can't be you got to.
I'm not touching it.
No,
I'm not, okay, I'm not touching it.
listen. You got that thing touching that board right there.
No, I don't. Maybe somebody else should write it.
Thank you. It's
You
okay.
know, the first day we did, I was.
Hey, stop talking.
I need to.
Let's focus on answering these questions.
Why write it so small? Write it lower. Because they can be bigger. Yeah, look how you got it.
I'm not doing the same.
Trey, tonight, y'all engaging with your class?
Yes, we're engaging.
Huh? Because you were turned away. Okay.
Stop.
Are you sure?
Because they told it, so it can't. We can do F17. Like him?
All right, that's 5 minutes. Grab a seat.
It wasn't 5 minutes.
It definitely
Keep right. It's not bad.
All right. Hey, group 6, grab a seat so we can get started, please. All right. So, looking around the room. F2 of x, yes. F2 of x, yes. Yes. All right, so all of us said yes to F2 of x. What told us F2 of x?
It's concave down.
Okay, so what's telling us concave down?
It's less than 2.
What is less?
-1/3.
Okay, so you're talking about your A, right? When you talk about that concavity, remember we need to refer to that A. A is less than 0, concave down. That works. Is that all I needed to know?
Yes.
Concavity is the only thing we gotta check. I was saying we also need to check the y-intercept. Remember, this is standard form. We're always looking at concavity and y-intercept in that standard form. What's my y-intercept? There's something you're missing. C is -6. That's not the y-intercept though. How do we write the y-intercept?
Oh, okay. 0, -6.
There we go. Remember, that's C, but 0 comma C is my y-intercept. I'm looking at that y-intercept, and I'm looking at that concavity. Hey, what you doing? Let's focus, take some notes. All right. So could that go with this graph?
Yeah.
Yes. I will also point this out. Could I check my vertex here?
You could.
I could and I should. I will say that. Maybe my line of symmetry. How do I calculate that line of symmetry out of that vertex, or that standard form? X equals... So H, yes, but from standard form it's what? -b divided by 2a. So what is the opposite of b? What is the opposite of -3? 3. Divided by 2 times a is -1/3. Now we'll point this out. I could put this in a calculator and simplify it, but I can stop here. Is that going to be a positive or negative x value? I've got a positive divided by a negative, so it's going to be negative. Does this have a negative x value for the vertex or the axis of symmetry?
Yes.
So is that good?
Yeah. Wait, how you get there right there?
How did I get this or this? Both parts?
Yeah.
This part?
Yeah.
Just this part, or
That part.
with use your words? Which the first or the second?
That right
Man,
there.
That
why
one.
you, bro?
Okay. So remember, this is off that practice sheet where we looked at how to calculate the axis of symmetry and the vertex from standard form. And so if x, so for that axis of symmetry, x is equal to -b divided by 2a. And so if I'm looking at this equation as ax squared plus bx plus c, my b is this -3. So the opposite of -3 is a positive 3. A is that -1/3. So divided by 2 times a. All I do is I pulled my a and my b out of that equation. And now that I know it's negative, that matches this having a negative x value, I'm good. I can simplify it, I can put that in the calculator, but I know it's a negative x value. Yes, Trayana? Okay. You think about it, let me know. I see F3, okay, F3 says no. They say concave up here, so is that a yes or no for this group up at the front?
Which one?
For F3?
No.
No? Okay. So we want to notice, could the x-intercepts work for F3?
Yeah. No.
Yes.
Remember, for x minus r1 and x minus r2, I need
It will be
the
the opposite.
opposite.
Oh, you.
So that'd be -1 comma 0 and -4 comma 0. So the x-intercepts, would the x-intercepts work?
Yes.
Yes, but the concavity does not.
No.
So x-intercepts would work, but concavity is wrong. Alright? Notice it's taking us a little bit more time with the explanations, but these are the things we want to notice. Okay? The x-intercepts work, but concavity is a no-go. Hey, why y'all talking? Take notes. So do not forget with those x-intercepts, I need the opposites. Okay? I'm going to start speeding it up so we have a chance to do one more round of this. I do not see anyone with F5 Oh no, we do have F5 right here, but I do not see F5 anywhere else.
We're not supposed to.
I know y'all wrote it over there too. Are we supposed to use F5? Or did y'all just write it up?
Yeah, we got to.
Yeah, we only had enough time to write that.
Oh, okay. Well, by the way, guys, you could have just written F2 of x, F5 of x, and not written out the full equation. I'm just asking you which equations, or which functions can we use. I told y'all just write up the ones that could go with the graph. Did we miss that detail? Okay, just write up the equations that could go with the graph. So could F5 of x, hey, focus, could F5 of x go with this graph?
No.
No, sir.
Concavity does not work, because that would be concave up, and because I need the opposite, would the x-intercept work?
No.
Nope. So nothing matches. Graph. Sorry for that miscommunication there. What about f6 of x? Why not? The x value of what? Be more clear with your language. The vertex. What would my vertex be in this case? 6, 3. Remember, I need the opposite of that h value. I need that k value. Notice that would be in quadrant 1, 6, 3. That does not match. Does the concavity work?
Yeah.
Yeah. So vertex does not work. Concavity would. But because one of them has a no, the answer is no. Right? Y'all still right? My bad. How's the class almost over already?
We actually paid attention.
Was that you that said that? I'm glad.
That was me.
Oh, okay. F7 of x.
No, but she said thank you.
I did not say that. You said that.
Alright, F7 of x. Yay or nay?
Yay.
Yay.
Yay, it works?
Yes. No.
I mean, the
It don't
concavity
work.
does.
Half of it does. So if only half of it does, it does not. What's the problem with F7?
The white.
No, it's a joke.
No.
Remember, what form is this?
No, that's factor.
You
We
making my brain.
gotta pay attention to the form. It is factored. Notice R2 would be a positive 3, so that does not work. Everything else did, but R2 would be a positive 3, so no, that graph does not work.
What?
R2.
What's your question?
With the free.
Huh? Okay,
So you changing that.
remember, for factored form, it's
Let's go ounce for ounce.
A times x minus R1 times x minus R2. So I'm not changing it. In order to get x minus 3, R2 had to be a positive 3. If R2 is a negative 3, I would actually get the plus in there. Remember, we always said we need the opposite for those parentheses. Right? R1 would be a negative 2. Okay. What about F8? What would my vertex be for F8? Negative 6, comma 3. I would say negative 6 to the left, 3 is up. David, Miracle, y'all focus? Doesn't sound like it. Concave down, so they all work. Alright, once you get those notes down, turn the page and move to part B.
Oh, no, we have enough time.
3 work. F1, F2, and F8. Alright, part B. Start working on that. For the sake of time, work at it on it in your small groups where you are, and we'll come back together in a minute.
Can you put this?
What's up? Okay, you have to identify the type of, the form of the function first. So like when I look here, what form are you looking at for that function?
No, I don't think I like it.
Is that standard? Is that factored? Or is that vertex based?
I don't know them by heart.
So we got to know them by heart. If you don't know them by heart, you're going to be struggling. So does that match this vertex form right here? Y equals a times x minus h squared plus k. A times x minus 75 squared minus 92. Yeah, that's vertex form, right? So now that I know it's vertex form, I can see the vertex, the line of symmetry, and the concavity like that. So you got to identify the form. Here, you see how I'm multiplying these two linear factors? So that's my factor form. I need to look at my R1 and R2. Here, ax squared plus bx plus c, that's my standard form. So you've got to know your forms so that we can then quickly know those features. Okay? Does that make sense a little bit? Okay. Make sure we study that. What does what say right where? Right where?
Back here.
What information? It's on my page.
Okay. I'm really confused what you're even looking at. Oh, yeah, that's literally on your paper.
Oh.
You talking about this?
No, I was talking about this one.
Ax squared plus bx plus c, where I'm circling the a and circling the b. Something on top of what?
X, R2.
Are you talking about this part right here? No. Whoa. This one? That's the factored form. A times x minus r1 times x minus r2.
You can do the milk. Give me $40. What it all?
Okay, so, can we go ahead and discover that?
The vertex is to the right and down. So you just focus on is it positive? Right. That's all it is, right? We're focusing on positive versus negative. That's why it says right here, right? Oh, that would be a negative value, and the x value is negative, it's to the left. Right? That's all that we're looking at. All we know is positive versus negative. And that's why it's just put it. Not necessarily does it, but just put it. Oh, hold up. Okay. I just realized we don't have time to go over these. We'll go over them tomorrow. Alright. Hey. Please hear me clearly on this. I was planning on having an understanding check tomorrow. I think we need to. I'm talking. So, I was planning on having an understanding check tomorrow. I am going to move the understanding check on forms of quadratic equations to Wednesday, which will push our test to Friday. I cannot push that test back any further. So, you need to start taking advantage of studying for both the understanding check and the test. Please do note that there is a new Carnegie Learning, or Mathia assignment, I should say. There are 2 quadratics workspaces. It is due Wednesday night, but it will help you study for that understanding check. I would go ahead and take a picture of that assignment and knock it out.
In the bottom.
Yay!
He was cute, bro.
Thank you!